All right, so before we get into the next theorem, there's a few things that we want to talk about, and that is the distance from a point to a line. All right, so when we talk about the distance, we're meaning the shortest distance possible. All right, so the shortest distance from this point A to that line L is when it is perpendicular. So it's when it's perpendicular to that line L. That means it's shortest distance. Yes, we can have A touch line L all the way down here, but since that is not perpendicular, it's not the shortest distance, or it's not the true distance. All right, and the same thing with this point B here. This segment is perpendicular, so that means this is the true length or the shortest length from B to that line L. Yes, we could draw a segment all the way down there, but once again, that's not its shortest or its true distance. All right, so the thing about this, let's say that you are going to your friend's house. All right, so here's your friend's house. I know, very good drawings, I know. All right, so here's your friend's house. Now, there is a road that goes to your directly, so here's a road that goes directly to your friend's house like this. And then your friend's house has a street that goes right in front of it here. So these two are perpendicular. All right, so we have that road. And then there's another road that you can take that goes all the way down here, that circles around, that comes back, and it connects to another road that's in front of his house right here. All right, so it connects to another road here, to another road on this side of it. Now, you would say that the shortest distance is this here. This is the shortest distance to his house. You wouldn't say, well, let's see, this is 2 kilometers away, but when I walk this really long distance all the way around, that one's going to be 10 kilometers. You wouldn't say, well, I live 10 kilometers from my friend. You would say I live 2 kilometers. All right, so when we're talking about the distance from a point to a line, we're always talking about the distance that is perpendicular, right? So it must be perpendicular to it. So this theorem is the angle bisector theorem and its converse. All right, so this states if you have a ray that bisects an angle, so they're telling us that ray QS bisects that angle PQR. So if they didn't give it to us, we know that these two are going to be congruent because they're telling us it bisects. All right, then it tells us that this point S is perpendicular to QP, and that this point S is perpendicular to QR. Right? So they're saying we're talking about the distance from S to QP. Yes, we can draw a line down here, but remember, since that's not intersecting it at a 90-degree angle, it's not its true distance. So we're saying the distance from S to the side of the ray. All right, so remember, it's intersecting at 90 degrees. We can draw another line here if we wanted to. So the distance from a point on the bisector to the side of the ray. And what we say is if we have an angle bisector, any point on that angle bisector is equidistant or the same distance to its ray. So that means these two would be congruent. If I draw a point here and intersect them at 90 degrees there, then that means that those two segments will also be congruent. All right, so any point on this line will be the same distance to the two rays. Right? And remember, in order for it to be the same distance, it must intersect at 90 degrees. So these would all have to be right angles. Right? And then the converse is the reverse. If I have a point that's in between the ray, so it's in the interior of an angle, so it's on the interior of an angle, and that point is the same distance to both of our rays, which here we know it is because they say it's intersecting at 90 degrees, so that shows the true distance, and it says that they're congruent, then that guarantees that that point falls on its angle bisector. So we know 100% that it is going to fall on its angle bisector. All right, so that's the theorem, and now let's do a couple examples with it. All right, so for this first example, they tell us that this angle is, that this ray, Rn, is in fact an angle bisector, right? It doesn't flat out give it to us in words, but they give us these two arc marks, so we know that it is its angle bisector. Then, since we know it's its angle bisector, and then they draw this segment RM and intersecting at 90 degrees, and this segment RP intersecting at 90 degrees, we know the distance from that ray to, or from that bisector to each of the rays is the same. So since they're perpendicular, we know that these two distances are going to be congruent. So we can say RM is equal to RP. And then we can just solve. So we can plug in RM is 7x, RP is equal to 2x plus 25. And then we will subtract over our 2x. So 5x is equal to 25. And then we'll divide each side by 5. and we get that x is equal to 5. Now, that's not what they asked us to solve for. They asked for Rm. So we'll plug it back in, 7 times 5. So Rm is equal to 35. Now, if you want to solve and make sure you do this correctly, you can plug in 5 back into the other one. So 2 times 5 is 10, plus 25 is equal to 35. So you know that you did this correctly since you have the same length. All right, and that's it for this video.